Hi, today we're going over sections 4.2 and 4.3, which are solving quadratic equations graphically. So when we're solving, we're looking for the roots of our quadratic function of the form ax squared plus bx plus c equals 0. And it can be done by finding the x-intercepts of a graph. So we can solve our quadratic equations by graphing them and finding our x-intercepts. So we'll do some examples of that. So first example is graph to find the roots of y equals x squared minus 2x minus 8. So I'll start with a table of values. Once again, I will go from -3 to +3 for x. And we'll start substituting in our values. So we would have -3 squared minus 2 times -3 minus 8. So -3 squared is 9. -2 times -3 would be 6. So 9 plus 6 is 15. Minus 8 gives us 7. Next, we have -2. So we have -2 squared minus 2 times -2 minus 8. -2 squared is 4. -2 times -2 is also 4. So 4 plus 4 is 8. Minus 8 gives us 0. Next, we have -1 squared minus 2 times -1 minus 8. So -1 squared is 1. -2 times -1 is +2. So 1 plus 2 is 3. Minus 8 is -5. Next, we have 0. We've got 0 squared minus 2 times 0 minus 8 gives us -8. Then we'll put in our 1. So 1 squared minus 2 times 1 minus 8. So we'd have 1 minus 2 is -1 minus 8 is -9. Next, we have 2 squared minus 2 times 2 minus 8. So 2 squared is 4. Minus 4 is 0. Minus 8 is -8. Next, we have 3. So 3 squared minus 2 times 3 minus 8. So 3 squared is 9. Minus 2 times 3 would be 6. So 9 minus 6 is 3. Minus 8 is -5. So far, we'll graph what we have and see if we need to do more terms. So at -3, we are at 7. At -2, we're at 0. -1, we're at -5. 0, we're at -8. 1, we're at -9. 2, we're at -8. 3, we're at -5. So you can see that we have part of our parabola. We so far have one of our x-intercepts, so we know that x is equal to 2, but this should be coming back up and crossing somewhere over here, so we'll do a couple more coordinates. So we'll do 4 and 5. So we have 4 squared minus 2 times 4 minus 8. 4 squared is 16. Minus 8 is 8. Minus 8 gives us 0. We'll do one more. So 5 squared minus 2 times 5 minus 8. So 5 squared is 25. Minus 10 is 15. Minus 8 gives us 7. So applying those new points, we now have our second x-intercept, which would be here. So that is at x equals 4. So solving this one, x is equal to 2 as well as 4. Okay, next example, graph to find the roots of -2x squared plus 3x minus 5. So once again, start with a table of values. Okay, so we'll put in our normal x values from -3 to +3. And we know y is equal to -2x squared plus 3x minus 5. So we'll substitute in -3. So we have -2 times -3 squared plus 3 times -3 minus 5. So -3 squared is 9. 9 times -2 would be -18. This would be -9. So -18 minus 9 is -27. Minus 5 is -32. So this is quite a ways off the graph. So I'd probably actually skip doing -2 and jump to -1. So I have -2 times -1 squared plus 3 times -1 minus 5. So -2 times -1 squared. So -1 squared is 1 times -2 is -2. And then we have minus 3. So that'd be -5 minus 5 is -10. So that will fit on our graph. So I will do the next one. So I've got -2 times 0 squared plus 3 times 0 minus 5. So I have -5. Next, I have 1. So I've got -2 times 1 squared plus 3 times 1 minus 5. So -2 times 1 is -2 plus 3 is +1 minus 5 would give us -4. Next, we have 2. So we have -2 times 2 squared plus 3 times 2 minus 5. So 2 squared is 4 times -2 is -8. -8 plus 6 is -2 minus 5 is -7. We'll do 3 next. So we have -2 times 3 squared plus 3 times 3 minus 5. So 3 squared is 9 times -2 would be -18 plus 9 is -9 minus 5 is -14. So we'll graph what we have so far. So at -1, we're at -10. 0, we're at -5. 1, we're at -4. 2, we're at -7. 3, we're off the graph. So our parabola would look something like this. So as you can see, it doesn't cross our x-axis. So therefore, this one has no solutions. Now we can tell before we graph it if it has no solutions, which would save us the time of doing table of values. To do that, we'll use something that we learned last chapter. So when the graph doesn't pass through the x-axis, there are no x-intercepts, so therefore no roots or solutions. So be careful before creating a table of values. It can be helpful to use our discriminant, because if you remember, our discriminant told us how many roots something had. If it was greater than 0, we had 2 roots. If it equaled 0, it was 1 root. If it's negative, we had no roots. Okay, so if we had done that with our previous example of -2x squared plus 3x minus 5 and put it into this equation, we would have had 3 squared minus 4 times our a value of -2 times our c value of -5. So we would have had 9 minus 40, which gives us -31, which would have told us that we had no roots, in which case I would have skipped doing the table of values and saved some time. Okay. We'll do some more examples. So graph to find the solution of y equals x squared plus 6x plus 9. So this time we'll run it through the discriminant first. So we had a b value of 6. So we have 6 squared minus 4 times our a value of 1 times our c value of 9. So we have 36 minus 36. So that gives us 0. So we should have 1 root. So we'll look at what that is when we have our graph. So we'll do our table of values. So we have x, we have y is equal to x squared plus 6x plus 9. And I'll change up the coordinates slightly this time. I will go from, say, -5 to -1. So we have -5 squared plus 6 times -5 plus 9. So -5 squared is 25. Minus 30 is -5. Plus 9 is 4. Next, we have -4. So -4 squared plus 6 times -4 plus 9. So -4 squared is 16. Minus 24 is -8 plus 9 would be +1. Next, we have -3 squared plus 6 times -3 plus 9. So -3 squared would be 9. Then we'd have -18. So -9 plus 9 is 0. Next, we have -2. So -2 squared plus 6 times -2 plus 9. So -2 squared would be 4. Minus 12 would be -8 plus 9 is 1. Next, we have -1 squared plus 6 times -1 plus 9. So -1 squared is 1. This would be -6. So 1 minus 6 is -5 plus 9 is 4. So at -5, we are at 4. -4, we're at 1. -3, we're at 0. 2, we're at 1. -1, we're at 4. So you can see this graph has one solution because we only touch our axis once, which would be here at x is equal to -3. So if it gives us one root, our vertex should be on the x-axis. Okay, next graph to find the solution of x squared plus 7x plus 10. Okay, so once again, start with our b squared minus 4ac. So we have 7 squared minus 4 times our a value of 1 times our c value of 10. So we have 49 minus 40. So that would be 9. So we know we have 2 roots. So we'll do a table of values. I'll start off with my usual -3 to +3. And we have our equation x squared plus 7x plus 10. Okay, so we have -3 squared plus 7 times -3 plus 10. So -3 squared is 9. 7 times -3 is -21. So 9 minus 21 would be negative 12 plus 10 is negative 2. Next, we have negative 2 squared plus 7 times negative 2 plus 10. So negative 2 squared is 4, minus 14 is negative 10, plus 10 is 0. Next, we have negative 1. So negative 1 squared plus 7 times negative 1 plus 10 gives us negative 1 squared is 1. This would give us negative 7. So 1 minus 7 is negative 6. Plus 10 gives us 4. We'll do 0 next. So we've got 0 squared plus 7 times 0 plus 10 gives us 10. Now, something's going on here, but I think we're getting further away from our vertex because our numbers are getting farther and farther apart. So I'll plot what we have to try and see what's going on. So at negative 3, we're down at negative 2. At negative 2, we're at 0. 1, we're at 4. And then at 0, we're at 10. So we can see we are getting further and further away from each other. So I'm guessing the other part of the parabola would come up over here. So instead of continuing to do numbers 1, 2, 3, I'll try some more for negative numbers like negative 4, negative 5, and see if that helps. So we have negative 4, negative 5. So we have negative 4 squared plus 7 times negative 4 plus 10. So negative 4 squared is 16. 7 times negative 4 is negative 28. So 16 minus 28 is negative 12 plus 10 is negative 2. So at negative 4, we are at negative 2. Next, we'll do negative 5. So negative 5 squared plus 7 times negative 5 plus 10. So negative 5 squared is 25 minus 35 would be negative 10 plus 10 is 0. Okay, so our parabola would look like this, and we would have x values of negative 5 and negative 2. Okay, practice for this section is on pages 283 to 291.